All right, everyone. Welcome to the 12th SI session that we're going to have for EE 2950. We're just going to go over the concepts in this video, and we're going to get into some problems in the later videos. All right, so just a quick review from the last session. Euler's equation. So we're going to have E is equal to I theta is equal to cosine theta plus J sine theta, which this is just the real part, and this is the imaginary part. Sinusoidal, so for voltage, we're going to have this in Vm cosine omega t plus theta. Then for currents, I of t, Im cosine omega t plus phi. If sine theta, therefore we will turn it into cosine theta minus 90 degrees. We want the real parts. And like we said, the real part is cosine. So we want this value to be cosine. Looking at the complex form, so complex form will be z is equal to z1 cosine, apologies, it'd be z1 e to the I theta. Then rectangular form would be z is equal to z1 cosine theta plus j z1 sine theta. Okay. And all it is we just take this z, pull it right there and right there, and we take that theta and pull it there and there. Now let's look at phasor notation. Phasor notation will just be z is equal to z1, and we pull that angle down. So all we are doing here is just pulling the z value down and then pulling that theta value in right there. So essentially the complex form and the phasor form are the easiest to transfer back and forth to. How do we get to complex form? Or how do we get to a phasor form and complex form from rectangular? All we got to do is say z1 is equal to square root x squared plus y squared, which is just the magnitude of the rectangular form. And if we want to find the angle from rectangular form, we'll just do tangent inverse y over x. And just for quick clarification, that's x, and this is y. Addition and subtraction. So addition will be, from the previous video, we said rectangular is the easiest form to work with when we're adding and subtracting. Multiplication and division, we're going to want to work in phasor. Like we said, let's just go ahead and do a quick example. 1 plus j2 is equal to a, b is equal to 3 minus j4. So if we do a plus b, we will get 1 plus j2 plus 3 minus j4. And all we'll do is add the reals together. So 1 plus 3 plus j, 2 minus 4. That would give us 4 minus 2j. So that just makes our math a lot easier. Let's do a phasor. So phasor, if we were doing multiplication and division, was to use the same A and B equations from up top. So if we do A times B, we're going to end up with, well, first we need to find the phasor of these two. Real quick, we'll just use our equations from the top. I already have these written down, so you can get some practice with converting these. But A is going to be equal to 2.23, an angle 63.43 degrees. Then B will be equal to 5 at angle negative 53.13 degrees. Okay. So A times B would be 2.23 times 5. It's just the magnitudes multiplied. And we'll add our angles. So 63.43 plus negative 53.13. And that'll give us 11.15 at an angle 10.29 degrees. If we do A divided by B, so A will be 2.23, 63.43, B 5, negative 53.13. We'll just divide the magnitudes out. So when we divide the magnitudes, we'll get 0.446. Then when we subtract our angles, here we'll subtract 63.43 minus negative 53.13. So it'll be 0.446, an angle of 116.56 degrees. So yeah, we can see quick examples of how we do those. We're actually going to break this up into 2 concept videos. So this will be concept video number 1.